In this section, we're going to look a little bit more about the vocabulary when looking at the graph of a function. More specifically, we'll look at intervals of increasing, decreasing, and constant, where a graph has a maximum or minimum, and finally, what the zeros of a function are. The first few terms that we'll describe are increasing, decreasing, and constant. Essentially, a graph is said to be increasing if it is rising from left to right. It is decreasing if it is dropping from left to right. And finally, if the function is staying the same, it is said to be constant. Now, you can look at all of these terms and realize that your intuition is going to help you out a lot. Your idea of when something should be increasing and decreasing actually matches the definition pretty good. One thing that you do want to be aware of, which will come up a little bit later on when I get to my example, is that when we describe where a function is increasing, decreasing, or constant, that we use only the x values to describe where this is happening. To get an idea of what increasing, decreasing, and constant looks like from looking at the graph, I've pulled up a graph here of g of x. Now, what I want to visually do is imagine places where the graph is increasing from left to right and decreasing from left to right. And to help out, I've color-coded all of those different spots. So the blue areas of the graph would be increasing, the green would be decreasing, and the purple area off to the right, that's where the graph is staying constant. Another good way that you can help yourself out visualize these different areas is to imagine the graph was a roller coaster, and you were on the roller coaster moving from the left side to the right side. Places where you're going up on that roller coaster, the graph is essentially increasing. And places where you're going down on the roller coaster, well, those are the places where the graph is decreasing. The next two terms we'll cover are the relative maximum and relative minimum of a function. Now, the definition for each of these can be a little tricky to decode, but don't worry, we'll get there in just a bit. So f of c is a relative maximum of a function if there exists an open interval I containing c such that f of c is greater than f of x for all x in I where x is not equal to c. You see what I mean about the definition? You can read it, but oftentimes it doesn't lend a whole lot of information what's going on there. Well, remember that when we plug in a value like c, f of c essentially represents the output. So what this is saying is that we're going to choose some value c as an input on an open interval. And when I put in that input, I'm going to get an output like f of c, and f of c must be greater than all the other values of f of x in that interval. Now, the relative minimum has a very similar definition. The only difference is that when you plug in that input of c, that it is now lower than the rest of the function on that interval. So, in a sense, here's what that definition means. You have a point that is called a relative maximum if it's greater than the rest of the function on some interval. And a point is a relative minimum if it's less than the rest of the function on some interval. Now take note, these are relative maximum and relative minimum. The difference is that you're looking on some open interval and not necessarily including the entire graph. So visually, let's see what's going on here. So notice I've brought back that graph of g. Now, it basically has a little peak on one side and a little valley in another spot. Well, just like our intuition says that it probably should be, those are the locations of the relative maximum and the relative minimum. And I color-coded them to make it a little bit easier to see. So that blue dot is my relative max, and the green dot is the relative minimum. Now, the reason why it really fits the definition is notice how that blue point is the highest point of the graph on some interval. Say an interval between -9 and -4 on the x. And that green spot, well, it's the lowest point of the graph between, say, -3 and 0. Now, take note that green really is a relative minimum and not the absolute minimum. Because if I was to travel further on the left side of the graph, I could actually get a lower point than my green spot. But the green spot is the lowest point on an interval, say between -3 and 0. Therefore, it really is the relative minimum. Now that you know a little bit more about increasing, decreasing, and constant, we're going to do a quick example using this graph, h of x. So the first thing I want to do is basically imagine places on the graph where it is either going down or say going up or staying constant. And again, I like to say color code these different sections just so I can see what's going on. So the green areas of the graph, those are places where it is decreasing. And the blue areas of the graph are places where it is increasing. Now if I inspect this graph a little bit, I notice that there are no places where it is staying constant. So I haven't color coded any of those. Now, as I go through trying to describe these different areas, we use only the x values of where it happens. So let's first describe the places where it's increasing. Those are each of the blue sections. So in the first blue section, if I use x values between -2 and 3, I can be sure that this graph is increasing. For the next section, if I use x values between 6 and infinity, again, it would be increasing. So I use those different ranges of x values to describe where it's increasing. So these are not points, they're x intervals or ranges of x values where it's going up. All right, let's do this one more time for decreasing. The first green section, I could use x values between -infinity all the way up to -2. And the smaller section where it's decreasing, I could use x values between 3 and 6. So those would be my two intervals of where it is decreasing. All right. Lastly, let's grab our relative maximum and relative minimum. Remember that to be a relative maximum, it's basically the highest point on the graph for some sort of interval. And the relative minimum is the lowest point on the graph, again, for some sort of interval. Use your intuition a little bit and look for the peaks and valleys of this graph. Now, looking at the peaks and valleys, it's probably not too hard to pick out where they are. So I have one peak that looks like it's somewhere around x equals 3. And I have two little valleys, one at x equals -2 and x equals 6. So those represent my relative maximum and my relative minimum. Now, notice how it's okay to have more than one relative maximum or more than one relative minimum. Essentially, you could have more than one little peak or more than one little valley. The last term that we'll learn for this section are the zeros of a function. And this is a really important one that shows up again and again in future sections. So a zero of a function is some value, let's call it c, for which when you plug it into the function, you get 0 as your output. Now, this is essentially, some x input where the entire function is equal to 0. Another way you can look at this, especially when inspecting the graph, is that these zeros are just the x-intercepts of the graph, or where the graph crosses the x-axis. So let's do a really quick example of finding the zeros of a function using this graph here, g of x. So inspect this graph and notice that there are places where it either crosses or touches the x-axis. Now at each of these spots, I would consider that a zero of the function. So I can see that I have one at -9, one at -1, and another one when x is equal to 5. So I'll describe these like this. When x is equal to -9, I have a 0. When x equals -1, or when x equals 5. Each of these is a zero of the function.